Welcome back. We'll now do a problem that I think will bring everything together, and frankly this is a fairly difficult problem, and if you get this problem you are on your way to becoming a physics master. So let's get started with this problem. So we have this setup here where we have a wall and the floor, and we have a wire or rope attached to the wall here, and then it goes around this pulley, and this pulley, for the sake of this problem, let's just say this pulley is somehow supported in the vertical direction so it doesn't fall to the ground. And then this wire goes back around the pulley and then it's attached to this 10 kilogram mass. And in this case, and this is the first time we're dealing with a pulley that actually has mass, this pulley has a mass of 5 kilograms. And even more, the pulley isn't even fixed. We are going to pull on the pulley. And we are going to pull on the pulley with a force. Let me get my pen tool set up because this is an exciting problem. We will pull on the pulley with a force of, let me make it clean lines, because let's say we will pull on this pulley with a force of 150 newtons. Somehow it's being compelled to go in that direction with a force of 150 newtons. Even more, the coefficient, so this pulley is somehow up in the air, it's being supported there, so we're not going to, we're not going to assume that it falls or something like that. It's just, it's only being pulled in the rightward direction, so don't worry about the up and down motion of it. But the problem also tells us that the coefficient of friction between this block and the ground, the coefficient of friction is 0.4. So I could write that here. Let's see, coefficient of friction is equal to 0.4. So the question is, what happens here? What happens? So in any physics problem, before you break into the numbers, I think it's always a good idea just to get a conceptual sense of what it should look like, what you would think would happen. So someone's pulling on this pulley, and this wire is staying fixed. So what's going to happen? They're going to pull on this pulley. The pulley is going to go more and more to the right. As the pulley goes more and more to the right, this top length of wire will get longer, and the only way that that top length of wire gets longer is if this bottom length of wire will get shorter. So the pulley will be moved to the right, and at the same time, this 10 kilogram mass will get closer and closer to the pulley. And if you think about it, whatever the velocity of the pulley to the right, the velocity of this 10 kilogram mass will be twice that. Why is that? Well, let's say this pulley moves 1 inch to the right. If the pulley moves 1 inch to the right, then this length of rope right here will get 1 inch longer, right, because the pulley went 1 inch to the right. And this length of rope, because the rope is of a constant length, we're assuming it doesn't stretch or anything, will get 1 inch shorter. So not only did the pulley move 1 inch to the right, but this rope down here got 1 inch shorter, so this block would have moved 2 inches to the right. Hopefully that makes sense. So if whatever the velocity is of this pulley, this mass's velocity will be twice as much. So similarly, whatever the acceleration of this pulley to the right, the acceleration of this block will be twice as much. And why is that? Well, acceleration is just change in velocity, and so if my velocity has doubled and this guy's velocity is double that, his change in velocity will be double that. I don't know if I just said a circular statement, but hopefully that makes sense. Just think about what happens. If this guy moves an inch, this length of cord will also get shorter by an inch. So the pulley will move an inch, and then this guy will get closer to a pulley, so he would have moved 2 inches. So his velocity and acceleration are double that of the pulley. And that's an important thing to realize. So with that out of the way, let's solve the problem. That really is kind of the big thing you should realize about this problem. So let's with that tucked away in the back of our mind, let's do the problem. So what are all the forces acting on this block right here? Well, we know it's going to be moving towards the right. It's actually going to be moving towards the right twice as fast as the pulley.
Nah, jika bergerak
So
ke
if it's
kanan,
moving to the right,
gaya
which direction
geseknya
is the force of
bekerja ke arah
friction
mana?
acting in? Well, the force of friction is always a spoiler.
Gaya
It's
gesek
always
yang
going in
selalu
the
bekerja
opposite direction.
berlawanan arah.
So you have the
Jadi
force of
kamu
the
punya
friction
gaya gesek
going
yang
backwards.
berlawanan.
Right?
Berapakah besar
And what
gaya
is that
geseknya?
force of friction?
Ia akan
Well, it's going to
sebesar
be the
berat
weight
dari balok
of
ini
this
kali
mass, this weight
koefisien
of this
gesek.
block, times the coefficient of
Karena
friction,
berat ke arah
right?
bawah,
Because the
maka
weight
besarnya akan
comes
sama dengan
down,
gaya
and that's
normalnya.
equal to the normal force, and the normal
Nah,
force
ini
is
sudah
equal to
kamu
weight.
tahu
You know all
sebelumnya.
of this already.
Jadi
So
gaya
the
geseknya
force of
akan sama
friction,
dengan
the
koefisien
force of
gesek
friction is
0,4
going to be
dikali
equal to the coefficient of
berat
friction,
dari balok
0.4,
Nah,
times
yang ini.
the weight of this block. And
Berapa
what's the
berat
weight of this
baloknya?
block? It's
10
going to be 10
kilogram, yaitu
kilograms,
masanya.
which is the mass, times the
Dikali
times the
kecepatan
acceleration of
gravitasi,
gravity.
yaitu
So that's 9.8, so it's 98 newtons.
98
I'm skipping
Newton.
some steps here because
Saya
I
akan melatih
think
beberapa langkah di
things
sini
like,
karena
you know,
saya rasa
what's
mencari
the
berat
weight of a
dari
10
balok yang
kilogram
masanya 10
mass
kilo kamu
block,
sudah
I think,
terbiasa
are
sekarang.
hopefully a bit of second nature to you now.
Jadi
So it's 0.4 times
dikali
0.98
98 Newton.
newtons. And if we get the
Mari
calculator
kita
out,
gunakan kalkulator.
that is
0,4 dikali
4 times
9. Maaf salah.
whoops,
Dikali
0.4
0,4 dikali
times
98
98
sama dengan
equals
39,2
39.2
Newton.
newtons.
Sama dengan
Equals
39,2 Newton. Nah,
So that's the
gaya
force of
geseknya
friction
dengan
going
arah berlawanan.
backwards on this mass.
Jadi apa yang
Well,
memaksa
what's
balok
compelling the
bergerak
block
ke
to
kanan?
go to the right?
Ini bukan.
What's this wire, this rope,
Tegangan tali
right?
inilah yang menarik
So
balok.
that's the tension in this rope
Kita namakan
is
dia
pulling
dengan
on this block. So we call that
namakan T.
T.
Jadi
Right?
berapa
So
total
what are the
gaya
net
dari
forces
balok ini?
acting on this block? And let's say,
Berapa
what are the
total
net
gaya di
forces to the
sebelah
right?
kanan?
Well, it's
Nah, ini
T,
T ya.
right, which is
yang
the force of
merupakan gaya dari
tension of this
tegangan
rope.
di
I
tali
could have done
ini.
it along the rope, but I just did it here. T is the force of tension.
Nah,
I'll draw it.
adalah
Actually, I
gaya
will
dari
draw it along the
tegangan.
rope, just so you know. It's the rope that's
Saya gambarkan
exerting this
sepanjang
force of
tali,
tension.
supaya kamu tahu
So the force of tension
adalah tali yang
minus the
memberikan gaya
force of
tegangan.
friction, which
Jadi
we
gaya
figured
tegangan
out to be
dikurangi gaya
39,
geseknya, maka kita
0.2
dapatkan
newtons,
39,2 Newton akan
is
sama
equal
dengan
to the net force
total
on this
gaya pada
object,
benda ini,
right?
bukan?
Is equal
Dia
to the
akan sama dengan
net force, at least in
total
the
gaya.
left, right, or horizontal direction on this object.
Dan
And that's
akan
going to be
sama
equal to
dengan
its mass
massa
times its
dikali
acceleration,
kecepatan.
right? The net forces
Total
on
gaya
an
dari
object
objek
are
ini
equal to
akan
its
sama
mass times
dengan
its
massa
acceleration. That's
dikali
Newton's second
percepatan.
law.
Itulah hukum kedua
So
Newton.
what's its
Jadi berapa
mass?
massanya?
It's 10.
Dengan 10.
And if we knew the acceleration,
Jika
we
kita
wouldn't have to do this
kecepatannya, kita
problem.
tidak harus
So we
mencarinya
don't know
dulu.
what it is, so
Tapi
let's
karena
just say
kita tidak
it's
tahu
A.
berapa besarnya, kita
So
sebut saja
10
A
times acceleration
kali A.
is
Jadi
A.
inilah
So
total
these
gaya
are
pada
the net
balok.
forces acting on
Nah,
this
karena
mass.
kita
And
tidak
we
tahu
don't know
berapa
what
A-nya,
A is.
kita tinggalkan dulu
So
saja.
let's put that
Tapi saya
aside a
akan
little
beri
bit.
kotak
Maybe
di
I'll
sekelilingnya.
put a little square around it. And let's figure out
Mari
what's
kita cari tahu
happening
apa yang terjadi
to the
pada
pulley
katrol itu.
itself. So this is interesting. The
Katrol
pulley
punya gaya
has this
yang misterius.
mysterious force, maybe it's
Mungkin
my
tangan
hand,
saya yang
pulling it at
menarik dengan gaya
150 newtons to the
150
right.
Newton ke kanan.
And what's pulling it
Tapi
to the
apa
left?
menarik ke kiri?
Well, in both
Dalam dua
cases,
kasus ini,
this
ini
wire is
ditarik
pulling it
ke
to the
kiri.
left. And the
Dan
tension
tegangan pada
throughout a
seluruh tali
wire is
tetap.
constant, right? Unless,
Kecuali
the
terjadi
material
perubahan
changes or
pada
something. Well, then
materialnya.
it shouldn't change.
Jadi tegangan
So the
pada tali
tension
tetap.
through the wire is
Dan
constant,
dalam
and
dua
in
kasus
both
ini,
cases,
tali menarik
the
katrol.
wire is pulling
Jadi
back on
jika
this
tegangan
pulley.
adalah T ke arah ini,
So if the tension here is T going in this
maka
direction, the
tegangan ke
tension
arah
in
ini
this
adalah
direction is T,
T. Dan tegangan
and the
pada
tension
arah
in
ini
this
juga
direction
T.
is also T.
Kita telah
And
mempelajari
we'll
katrol
learn
saat
more
kita
about
membahas
pulleys when
keuntungan
we start
mekanik
doing
dan
mechanical
bagaimana ia
advantage
dapat
things and
melipat
why,
gandakan gaya yang
how it
dibutuhkan.
doubles
Namun
the
jaraknya
force needed,
berkurang
but the distance
setengahnya
goes in half, and
dan
all of
sebagainya.
these type of things, and we'll do
Kita
that
akan
later.
dilakukan.
But all you have
Tapi
to
yang
realize is
dipahami
that the
adalah
tension
tegangan di
through the
sepanjang tali
wire
adalah
is
tetap.
constant,
Dan katrol
and
ini
this
terdapat
pulley
tali
essentially has
yang
the wire pulling on
menariknya
it
pada
twice,
tempat,
right?
kan?
One's on
Satu di
top
atas
and
dan
one's
satu
on
lagi
the
di bawah.
bottom.
Jadi berapa
So what are the
total
net
gaya yang
forces
bekerja pada
acting
katrol
on this
ini?
pulley?
Kamu
Well, you
punya
have 150 newtons
ke arah kanan,
to the right,
dan
150
terdapat
newtons
gaya
to the right,
tegangan pada
and then it has a
245
force of
ke kiri,
tension
kan?
twice pulling to the
Karena
left,
tali
right?
mengelilinginya.
Because the wire wraps around it.
Jadi minus
So minus
2T.
2t.
yang sama dengan
And that equals the
massa
mass
dikali percepatan
times the
dari
acceleration
katrol.
of this pulley. So
Maka
that's the
massanya
mass,
yaitu
which is
5
5 kilograms,
dikali
times the acceleration
kecepatan
of
dari
pulley,
katrol.
times the acceleration, alright, the acceleration of the pulley.
Dan di
And
atas
this
ini
one up
sedangkan
here
adalah
was the
kecepatan
acceleration
balok
of the
atau
block.
AB.
And what did we?
Paling
What was
kita
the
ketahui
first
dari
thing
soal
that we
ini
discovered about this problem?
bahwa
That the
percepatan dari
acceleration
katrol
of the pulley
sama
is
dengan
equal to
setengah
half
dari
the
kecepatan
acceleration
balok.
of the block,
Atau
or
percepatan
that the
balok
acceleration
adalah
of the block
2
is
kali
2
kecepatan
times the
katrol.
acceleration of the pulley. Either way,
Itu
that was the
adalah hal
first thing
pertama
that
yang kita tahu,
I went off about, how,
bahwa
you know, the pulley moves an
katrol
inch,
bergerak 1
and at the same
inci,
time
pada saat
this
bersamaan
bottom
bagian
part of
bawah
the
tali
rope gets short, or wire gets shorter by an
bergerak
inch,
1
so this thing
inci,
moves twice
yang
as
ini akan
fast,
bergerak 2
right?
kali lipatnya.
So
Kita
let's
substitusikan di
substitute
sini
here
untuk
for the
kecepatan
acceleration
balok.
of the block.
Jadi percepatan katrol adalah
So the
setengah
acceleration of the
kali
pulley is 1/2
kecepatan balok.
times the acceleration of the block. So let's
Kita
substitute. So we
dapatkan
get 150 newtons
150
minus 2 times the tension of the wire is equal to 5
5
times, instead of the acceleration of the pulley, it's 1/2 the acceleration of the block. 1/2 the acceleration of the block, of this block here. And now let's try to solve.
Persamaan ini belum selesai.
Well, we don't want to solve yet.
Kita
Well,
akan
we have to somehow
tegangan
substitute for what the
talinya.
tension of the wire is.
Mari kita
So let's
lakukan
do
itu.
that. And actually,
Namun
I'm
tulisan yang
getting
ada sudah
frustrated because I
kepenuhan.
realize I
Kita
only
hanya
have
punya
10 seconds
detik
left.
lagi.
So I will
Kita
see you in the
bertemu lagi
next
di video
video.
berikutnya. Sekian.